We are here at Top of Ledges in gorgeous Hinckley Reservation, talking a little bit about rock climbing. This is not meant to be like the end-all be-all video. This is just a short little introduction to anchor building for rock climbing. So please use this as a refresher or use this as a resource as you are practicing and learning these skills. So first thing with anchor building, you can see here we have two monstrous trees and we have two anchors. So we have the green rope coming out here to what we'll call the master point, and then we have this white rope around this tree coming out to what we call the master point. So here we kind of have our imaginary cliff edge, this stick being our cliff edge. And you can imagine this being our master point, and this is our cliff. So a climbing rope would go the whole way from the ground up through our master point and then back down to the ground. So as the person climbed, the belayer could take in the slack. That way if the climber falls, they're only falling how much that climbing rope stretches. So this is kind of a basic top rope anchor setup. Super easy, super simple. There's not a lot to kind of mess up here. But we want to talk about the principles, which is why we have this whiteboard. So big thing is each leg of the anchor, you want to be equalized. So we're going to have my white rope is one leg and this green rope is another leg of the anchor. So I want these to kind of each take the same amount of load. So we'll do simple math. If I have 100 pounds and I'm just pulling, this isn't falling, right? There's more forces involved when we're climbing. But if I have 100 pounds, I want 50 pounds to be on this white anchor, and I want 50 pounds to be on this green anchor. So that is what we mean by equalized. When we talk about angle, we're talking about this right here. So in math, I'd have to draw my little loop right here, and I could write 20 degrees or 10 degrees or whatever it is. So you want your angle to be as low as you possibly can. So these two trees are kind of in line with each other. So this is really strong. If my other tree, so let's just say my tree was over there and over here, and I had one tree going back this way and one anchor going back that way, I don't want this angle now between these two ropes to really ever be more than 90 degrees. So if you have two legs in your anchor, you really don't want it to be more than 90. If you only have if you have three legs in your anchor, you don't want that to be more than 90. If you only have two legs in the anchor, like we do here, you really want it to be just like 60 degrees. And the reason for that is if it's really far apart like this, if I pull on this, and this is a 100-pound weight, if your anchors are spread really far apart, you're actually applying more than half of the weight to each anchor. And at a certain point, you are actually doing more than 100%. So it's kind of a hard thing to understand until you're doing it. But just understand for the purpose of this and kind of as a refresher and learning, you want to keep that angle as low as you possibly can. It's going to be a better anchor. The next thing is redundant. So as you can see, we have two here. These are monster birch trees. They're not hollow. They're growing. They're really well. We've padded them. So you want your anchor to be redundant. So that's why we have two anchors here and we have two carabiners. That way, if something in my system were to fail here, the white rope, this carabiner, that tree, or any piece of the green one, you still have another anchor. So with that, redundant definitely means two. But if these trees were a lot smaller, maybe you want 3 anchors. Maybe you want 4 anchors, okay? So it just depends. You need to be redundant and have enough anchors. No extension, same thing as kind of backing this up. If my white anchor were to fail, I do not want my master point where my climbing rope goes through to shift left, right, or down. So I want this to be this way, whereas if I had this over here and this anchor were to fail, I would be swinging. My master point would move. So you don't want your master point to move. If any one link in your safety chain were to break, you don't want your master point to move. So that's what no extension means. You want this to be strong. Kind of already mentioned the size of trees. These are huge, monstrous, big things. I'm not going to give you a math formula that says you need to have 3 trees that are at least 8 inches and alive, or 2 that are 12 inches or 14 inches. But you need to be able to assess your anchors that they are strong. And that's both macro structure, so nice, big, strong, good root systems, and then also microstructure. So if I was slinging a boulder on top of a cliff as an anchor and it was monstrous and the size of 8 school buses, but it had like a really thin, sharp point on the back that your rope was gonna get cut through, that's not a good anchor. So think micro and macro structure when you're thinking about strong. And the last thing is timely. This shouldn't be the focus, but you should be able to set up climbs fairly quickly, and that just points to the simplicity of it. It shouldn't be really complex. Make sure you have enough equipment that you can do what you want, where you don't have to try to piece things together and kind of make something work. Invest the time so that as you're building anchors in rock climbing, you can really use this EARNEST acronym as a good reminder. And hopefully, find someone that you like to climb with, get out there, learn together, practice, kind of use the resources of other more experienced people that have been out there climbing, and hope to see you out here. Thanks for joining.